Hello class, today we are going to look at the volume of pyramids and cones. So in previous videos we had looked at the surface area of pyramids and cones, and we had looked at the volume of prisms and cylinders. Here we're going to look at the volume of pyramids and cones. So here we go. Start with the pyramid. Volume of a pyramid is 1/3 BH. This is a big B, not the little b. So the big B there, this is the area of the base. All right. And then H will be the height of the cone. Notice this is the height of the cone. It is not the slant height of the cone. All right. Slant height, remember we used that. Oh, sorry, not the cone. This is not the slant height of the pyramid. We want the height of the pyramid. Getting ahead of myself. All right. So if you remember, slant height was used on surface area because it was on the surface of the pyramid. We want the height there inside the pyramid because volume is how much space is inside the figure. All right. Now, one other thing, real quick. Notice this does work for right pyramids. So, a right pyramid, what that is, that's where the apex is directly over the center of the base, and it also works with oblique pyramids, where the apex is not directly over the center of the base. All right. So remember from the previous video, this is Cavalier's principle, says that if the cross-sectional area is the same all the way up as this other one, then the volume is the same, which means we can use the same formula whether it is a right pyramid or an oblique pyramid. The formula still works, all right, which is good. That means we don't need more formulas. So let's go ahead and do one of these. Let's find the volume of this pyramid. And I got the formula for us right here. Volume is 1/3 area of the base times the height. Now let's see which one of these is the base. Well, since they're all triangles, we'll just assume the base is the one it's sitting on. All right. So this is a triangular pyramid. If it wasn't a triangular pyramid, then the base is whichever one is not the triangle. Because for a pyramid, all of the lateral faces have to be triangles. So this one here, this is a square pyramid. The one we have over here is a triangular pyramid. And we could use any of the triangles to be the base, but since this one's a right triangle, that's going to be the easiest one to use, so let's use that. All right, so here we go. 1/3 area of the base, right? Well, the base is a triangle, so area of a triangle is 1/3 base, 1/2 base times height, right? So 1/2 base of the triangle, little b, right? And then height of the triangle, so 4 times 6. So this right here, this is the area of the base times the height of the pyramid. Not the lateral height, not the slant height. We want the actual height there in the middle of the pyramid. How tall is the apex? Which is 9. And then we just work that out, and we get an answer. We just stick it in the calculator, and there you go. So not too bad. Pretty easy stuff. Okay, so let's do one more. Here we'll have this one, and I would like for you to pause the video and work this one out on your own. Okay, you're back. Let's see how you did. So first things first, this is obviously an oblique pyramid. All right, the center is off to the side. It's not, the apex is not above the center of the base. And what kind of pyramid is this? This is a hexagonal pyramid, which means the base is the one that's not the triangles. It's the hexagon. Right? So that's going to be a little bit more problematic, but we'll work this out. So remember, the area of a hexagon, a regular hexagon, a regular any polygon, is 1/2 the number of sides times the length of the side times the apothem. 1/2 perimeter times apothem. And then the height of our pyramid. So that's not too bad. So we've got 1/3, 1/2, number of sides is 6, the length of the side is 12, and the apothem is, I don't know that, but the height is 20. All right, so we got that. So we're going to have to work out the apothem here. And so to do that, what we're going to do is we're just going to take this hexagon, remember, and we're going to pull it out like this. And remember, the apothem is the segment from the center of the hexagon to the midpoint of one of the sides. Right? And since this is a regular hexagon, that will be perpendicular. So what we're going to do is we're going to use this right triangle right here, and we'll use some trigonometry. So if I know the entire side is 12, that means this is going to be 6. Now to use trigonometry, I have to find this angle right there. And the way we do that is 360 divided by 2 times the number of sides. So 6 in this case, because it's 6 sides, not this 6th number of sides. And that gives us 30. So that angle is 30 degrees. All right. So we've got 30 degrees there, which means this is actually a 30, 60, 90 right triangle. So if you wanted, we could use a shortcut there. But since this might not on your homework be a hexagon, it could be something else, it probably won't be a 30, 60, 90. So we'll go ahead and do it with trig. And so let's see, I've got this angle, I've got that side is opposite the angle. The apothem is adjacent to the angle, so that's opposite and adjacent. That will be tangent from SOHCAHTOA. Right? Opposite and adjacent. So tangent. So where did my thing go? It is, where did it go? There we go. Tangent. All right. So tangent of the angle is equal to opposite, 6 over adjacent, which is A. We want to get the A by itself, so remember the ratio here and the A switch places, and so it becomes this. A is equal to 6 over the tangent of 30 degrees, and I am going to take all of this and plug it in for A. That way there's no rounding going on. So I have this. And now I'm going to take that and I'm going to stick that into the calculator just like that. Where's my calculator? There it is. All right, clear that out. Okay, so we have 1/3 times 1/2, and we'll use the decimal because it's faster, times 6 times 12 times 6 divided by the tangent of 30. Let's make sure I'm in degrees, and yep, I'm in degrees. 30, close parentheses, close the other parentheses, and then times 20. All right. And I get an answer of 2494.153, so approximately 2494.15. Okay. All right, so this is a little bit annoying, but that's because it is a regular polygon, not a square or a triangle or something like that. All right. Okay, let's take a look at cones now. Volume of a cone is 1/3 base times height. Just like we saw with prisms and cylinders, cones and pyramids have the exact same formulas, 1/3 base times height. The only difference is with a cone, the base is always the same shape. It's always a circle. So we can say instead of base times height and then figure out what our formula for base is, we can just use pi r squared. Because it's a circle and the area is pi r squared. Again, notice we want height, not slant height. We want the actual height right there. If it gave us the slant height, we just use, got a right triangle there, so just Pythagorean theorem to get it. All right. Also, notice this works for right cones. It also works for oblique cones. Right cone, the apex is directly over the center. Oblique cone, the apex is not directly over the center. But the formula works either way. So let's do one of these. Okay, so we've got an oblique cone here. We've got a formula. And we want the volume, so we're just going to start plugging stuff into the formula. See, r is the radius, so that's 2.2, and h is the height, 4.5. So we plug those in, and then we can just stick that straight in the calculator like it is. Now, first things first, it's usually best if you plug the numbers in not with the pi. So, for example, once you answer in terms of pi, so you'd have 1/3 times 2.2 times 4.5, and this gives your answer. Oh, I forgot to square it, didn't I? Don't forget to square your radius. There we go. Got to square that radius there. That's better. Okay, so if you do this, you get your answer in terms of pi, and depending on what the question asks you, it may want it like that. This is the exact answer. Notice there's no rounding here. This is exactly what it is. Now, to get the answer that would be useful, for example, if you wanted to build something like this or whatever, then you multiply it by the pi, and we have 22.8079, so approximately 22.81 cubic centimeters. All right. All right, so I would like for you to solve this one. So pause the video, then come back and check your work. All right, you're back. Let's see what we got here. So we've got the radius, and that is not the height, is it? That's the slant height. So let's plug in what we got. We have that, right? 1/3 pi r is 5 squared times, I don't know yet. So that's fine, we can work it out. Notice we've got a right triangle. I know two sides of this right triangle, so we're just going to do Pythagorean theorem. A squared plus b squared equals c squared. And remember, the hypotenuse is always the wrong side, that's always c. And so your slant height is always going to be the hypotenuse. All right, so where did I put that? There it is. So a squared plus b squared equals c squared. Get h by itself. Simplify that. 8 squared minus 5 squared is 39, and so we want the square root of 39. All right, so I'm just going to plug that in like that so it's not rounded, and then we will type this into the calculator. So now that I have all my numbers, 1/3 times pi times 5 squared times the square root of 39, like that. And I'm not going to worry about getting this one in terms of pi because the square root of 39 is a hideous decimal anyways, so it's not going to be exact. And so we get 163.493, so approximately 163.49 meters cubed. Remember, volume is always in cubic units. All right, so let's take a look at this. Not a big deal here. We are just starting with the volume and finding the missing measurement, which in this case is the radius. They've given us the volume, given us the height. We want to find the radius. So basically, we're just going to take this and work it backwards. Start by write down your formula, right? 1/3 pi r squared h, because this is a cone, so pi r squared. Plug in what we know. I know the volume is 351 pi. I don't know the radius. I know the height is 13. Now we're just going to solve for r. So first thing we're going to do is since all of this is multiplication, we're going to divide it. Everything except for the square there, right? So we're going to divide by 1/3. We're going to divide by 13. We're going to divide by pi. And when you do that on both sides, all of that gets canceled out. Pi's cancel out over here, cancel over here, the 13 cancels out, the 1/3 cancels out. And so we end up with 81 is equal to r squared. I don't want r squared, I just want r. So we take the square root of both sides, and the square root of 81 is 9. Well, technically it's 9 and -9. Everything has 2 square roots, but remember, we're looking at distance here, and distance can never be negative, so we just want the positive one. And so the radius is 9 inches. Not too bad, not too bad. How about we do this one? Pause the video and solve this one. Looks like we're looking for the height is what we're missing here. So see if you can work that out, and then come back and check your work. All right, let's see how you did. So this one is a pyramid, so we're going to use the pyramid formula. 1/3 base times height. Plug in what we know. I know volume. Let's see, the base on this one is a triangle again, so let's see, 1/2 base times height of the triangle. I do have both measurements for the triangle, so we can plug all of that in. Volume is 24, 1/3 for the for the pyramid, 1/2 for the base for the triangle, times the base of the triangle, times the height of the triangle, and then height of the pyramid, which we don't know. So we'll start by multiplying all of this together, because it's all multiplication, and that gives us 3. So we have 3h equals 24, divide both sides by 3, and we end up with h is equal to 8. So the height is 8 meters. So that one was pretty simple. That was a lot easier. Okay, let's see. One last thing. Composite solids. That's where you have more than one thing put together. So on this one, obviously what we have here, we have a prism and we have a square pyramid, because it's on a square, 6 by 6, square pyramid. So the way we do this, probably already know, is you find the volume of each piece and we're going to add them up. So the volume of the solid is going to equal the volume of the cube plus the volume of the pyramid. So we'll just put in our formulas. Volume of the cube Well, that's a prism, so that's base times height. Volume of the pyramid is 1/3 base times height. Notice I use the same color here. Base here and base here, it's the same, because the base of the prism is the same as the base of the pyramid. The height, well, actually in this case it is. I could have used the same for height, but whatever. So we plug stuff in. For the prism, I have 6 by 6, so that's 6 squared, and then the height is 6. For the pyramid, it is 1/3 the same 6 squared, right? 6 by 6, length times width, times the height, which is 6 again. Again, when we're using height, we are not using slant height. And then you just stick that in the calculator. And what do you get? You get 216 plus 72, which is 288. So the volume is 288 cubic meters. And I would like for you now to solve this one. All right, so you got a cylinder and a cone. Pause the video and find the volume of the entire solid. Okay, you're back. Let's see how you did. So the cylinder and a cone, so obviously we're just going to find those and add them up. Volume of the cone plus the volume of the cylinder. Let's get our formulas there. Volume of the cone is 1/3 pi r squared h. Volume of the cylinder is pi r squared h. So this, I want the height of the cone. Here, I want the height of the cylinder, which is two different things there. Plug in what we know. Well, for both of them, the radius is 3, because it's got the same circle there. For the cone, we have a height of 5. For the cylinder, I have a height of 10. So first, I'm going to work this out in terms of pi, which gives me 15 pi plus 90 pi. So I'd have a total of 105 pi. So if the question asks for the exact answer, or if it says in terms of pi, you leave it with that. Basically, you just leave that pi to the end, because again, pi is dessert, it goes last. All right? And so then if you want an answer rounded off to the nearest hundredth or whatever, you just multiply that out, and there you go. So the volume of the solid is approximately 329.8672, on and on. So about 329.87 cubic centimeters. And there you go. That is volume with pyramids and cones. Remember, it doesn't matter if it is an oblique cone or a right cone, works the same. We use the height, not the slant height. And if it gives you the slant height and you need the height, it's just Pythagorean theorem. All you're doing right there. Remember that they both use the same formula. Area of the base, 1/3. 1/3 right there. 1/3 area of the base times the height. The only difference is with a cone, that base is always going to be pi r squared. If it's a pyramid, then it's going to depend. Are you having a triangle? Do you have a hexagon? Is it a square? So with a pyramid, it's going to differ based on whatever your base is. But if it's a cone, it's always going to be a circle. So pi r squared. Hopefully you found that useful, and I will see you in the next video.